Imagine you're trying to solve a really tough puzzle, one so complicated that even the world's fastest supercomputer would need years to figure it out. That's where quantum computing comes in. But don't worry, you don't need a physics degree to understand it. Let's break it down. Every computer you use today, from your phone to NASA's supercomputers, relies on bits. A bit is the smallest piece of information in a computer, and it can only be a 0 or a 1, like a light switch that's either off or on. Quantum computers, however, use something called qubits. And here's where it gets strange. Qubits can be 0, 1, or a mix of both at the same time. This special ability is called superposition. Think of a spinning coin. While it's in the air, it's not heads or tails yet, it's kind of both. That's a qubit. Another quantum trick is entanglement. When qubits become entangled, changing one instantly affects the other, even if they're far apart. Einstein famously called this spooky action at a distance. Why does this matter? Because it allows quantum computers to link qubits together in ways that make them work as a team, solving problems much faster than ordinary computers ever could. In a classical computer, if you want to test every possible answer to a problem, you have to go one by one. But in a quantum computer, thanks to superposition, you can test many possibilities at once. It's like having millions of workers solving different parts of a puzzle simultaneously, while a classical computer has just one worker going piece by piece. This doesn't mean quantum computers are faster at everything, but for certain problems like cryptography, drug discovery, and complex simulations, they're potentially revolutionary. Now let's take a look at some real-world examples of quantum computing applications. In medicine, quantum computers could help design new drugs by simulating molecules at the atomic level, which is, honestly, something nearly impossible for normal computers. In finance, they could model markets more accurately, helping detect risks and opportunities. And for logistics, just imagine optimizing routes for millions of delivery trucks in real time. A quantum computer could crunch those numbers far more efficiently. Now, before you get too excited, there's a catch. Quantum computers are incredibly hard to build and maintain. Qubits are extremely sensitive. Even a small vibration or a tiny bit of heat can cause them to lose their quantum state, a problem scientists call decoherence. That's why most quantum computers today operate at temperatures colder than outer space. And while companies like Google, IBM, and startups around the world are making big progress, we're still in the early stages. Think of quantum computers today as the bulky 1950s computers, giant machines that could only do simple math compared to what your smartphone can do now. So, should you throw away your laptop? Not at all. Quantum computers won't replace your everyday devices. Instead, they'll work alongside classical computers, tackling problems that traditional machines can't handle. In the future, quantum computing could transform industries, make scientific breakthroughs possible, and even challenge how we think about information itself. So, here's the simple version. Classical computers use bits, 0 or 1. Quantum computers use qubits, 0, 1, or both at once. Superposition plus entanglement equals the power to solve problems beyond our imagination. Quantum computing isn't magic, but it's close enough that it feels like it. This is the Life Pulse. If you enjoyed this crash course in quantum computing, don't forget to like, share, and subscribe for more fascinating explorations into the science shaping our future, and all the things that make life so interesting. And if you want to dive deeper into the quantum computer rabbit hole, let us know in the comments and we'll make a video about it. Until next time, stay safe, smart, and curious.